Alright, so this is the explanation for the fan cart with a constant velocity to the left or a negative direction. Um, as I said in the last video, it was kind of impossible to get a constant velocity with the cart, so we got the best that we could. I had to strike out data both on the left and right side to try to get this almost linear data right here on our position time graph. So for our position time graph, we have this data right here, this equation, and our slope and y-intercept. Our y-intercept is negative 2.587 inches, which means at time equals 0, our cart was negative 2.587 inches behind the initial position or starting point. And our slope over here is negative 9.677 inches per second, which is just our average velocity for the cart, for the fan cart in our time interval. Uh, this this graph and this slope does go with what we were expecting for a fan cart moving to the left with a constant velocity. It is in a negative um, area, going in a negative direction. If it's exactly what we were thinking, but for our velocity time graph, not exactly, because we didn't get a horizontal line, which we wanted for it to be a constant velocity. But we did end up with in the negative area of the graph, which is under the x-axis, which is good, which is good. Okay, so over here we have our equation y equals mt plus b. This is basically saying our velocity equals our slope times our time plus our v naught, and it'll give us our velocity anytime between the time interval that we have here. Our slope should have been 0 since we wanted a horizontal line for our velocity, which would give us a constant velocity, but we had a slope or an acceleration, in other words, which was 3.008 inches per second squared. Our y-intercept is negative 12.79 inches per second, meaning at time equals 0, we had an initial, our velocity was negative 12.79 inches per second. So our cart started at negative 12.79 inches per second. This slope is saying that the car is decreasing in velocity as it approaches 0, but which is wrong. We wanted a constant slope. Constant velocity, which would have given us a slope of 0, but as I said, this is the best that we can do. Over here I got the integral for our velocity graph, which is just the area under a velocity graph, which, if you remember, the area under your velocity graph is also your change in position. And our change in position, as it says right here, is negative 8.407 inches, which, if we look at our position time graph, our position goes from, I'd say, negative 7 to, what is that, like negative 16, negative 8 to negative 16, negative 7 maybe to negative 16, which is approximately what our integral is. So that's that again. Yeah.